This is Unit 3, Day 7. We're starting off with example 44 here. It says completing the square and shifting parabolas. Parabolas can be moved horizontally and vertically by simply manipulations of their equations. This is known as shifting or translating a graph. So if you guys can remember back into geometry, we'd do translations. They were called shifts or slides or glides. Kind of the same idea here. So example 44 says the function y equals x squared is shown already graphed on the grid below. Consider the quadratic equation whose equation is blah, blah, blah. All right, use the completing the square method, write this equation. All right, so what I do is, looking at your given equation here, you want to isolate the x terms. So I'm going to subtract the negative 18 to the other side. But I always just put my x terms on the left. So that c value becomes opposite on the opposite side of that equation. Now you have to take your b, you divide it by 2, and you square it. So this is my b, so I have to take negative 8, I divide it by 2, I get negative 4, but then I square it and I get 16. So I have to add 16 to both sides of the equation. Oops. Okay, and then you're going to factor this old school, but you're going to see it's called a perfect trinomial, meaning what two numbers multiply to give you a positive 16 but would add? They're going to be x minus 4s. This will be true that they always, always, always are a match. So the little shortcut would be you just take the square root of your new c and then the sign of your b sticks. So I knew that the square root of 16 was 4, and because b is negative, those are minuses. Okay? Now, we write those together as quantity squared, and then negative 18 plus 16, I'm going to get my negative 2. All right, now you want to move everything back to one side, and I'm going to get y equals x minus 4 quantity squared plus 2. And there is my complete the square method, okay? That's also known as, and you guys are going to see this, it's called vertex form, okay? All right, part B, describe how the graph of y equals x squared would be shifted to produce that graph. All right, well, you have to memorize that whatever's inside the parentheses is the movement of the x. So x normally moves left and right. But because it's in the parentheses, it is opposite. So when you normally think minus 4 would be 4 to the left, that really means you're moving 4 to the right, okay? And the number on your outside is always your shift of your y, and that is always exactly what it is. So y moves up or down. So because it says plus 2, you'd move up 2, okay? So just remember what's in the parentheses is opposite. So that's going to be 4 to the right and 2 up, or up 2, or right 4, up 2. Sketch the graph of this. Okay, so now remember, it says what are the, using its vertex form? That's what we just did by completing the square. And watch how nice this is. The vertex is the opposite sign of what's in parentheses. So it's positive 4, and then the 2 stays as is. So that's my new vertex on my graph. So if I go up here and graph it, I go over 4, up 2. That's my new vertex or my turning point on my parabola. Okay, so here is my new shift. Oops, that one's a little crooked. Let me redo that. Still don't like it. There we go. It's a little bit better. So this is y equals x minus 4 quantity squared plus 2. Now what's going to happen now is these are just the directions on how to complete the square. And again, you'll notice right here, that's really just b divided by 2 instead of doing 1/2 times b, quantity squared. All right, example 45. The algorithm of completing the square works best when a is equal to 1 and b is an even number in the form. But it does work in every case, even the messy ones. Okay, so what you're going to do is you are still going to move that 2, that negative 2 to the other side, okay? So it's going to become 3x squared plus 12x equals positive 2, okay? Then what you're going to do is on these x terms, you just factor out so that this coefficient is a 1. So I'm going to factor out a 3, and I'm left with x squared plus 4 equals 2. Now, here's my new x terms, and I'm going to complete the square in here. So this, oops, I forgot my x there. Let me throw that back in there. So my b is positive 4. So off to the side, I'm going to go b divided by 2. That's 2. But then 2 squared is going to give me a 4. But be careful, okay? If you write x squared plus 4x plus 4, you're not going to add 4 to the other side. You have to add 12. Because don't forget, we factored out a 3. So you're going to add 12 to the other side, okay? Because it's 3 times 4. Okay, so now we're going to factor this as usual. So if you guys use my little shortcut I just explained in the last example, you know it's going to be positive because the sign on b is positive. And then the square root of my c, which is 4, is 2. Okay, and that's equal to 14. Last step, you're going to move the 14 back over to this side, which would make it a subtraction. And I'm going to get y equals 3 parentheses x plus 2 quantity squared minus 14. Okay, it also says identify the turning point. So remember, guys, it's going to be the opposite sign of what's in the parentheses. So my turning point, my x-coordinate is negative 2, but then my y value is negative 14. That stays the same. Okay? Part B, same thing. So ready? 2x squared plus 6x equals negative 1. Factor out the 2, and I'm left with x squared plus 3x equals negative 1. Now my b is 3, okay? Now you might not like that because 3 divided by 2, don't give me decimals, just keep it 3 halves. But now I have to square that, so when I square 3 halves, I end up with 9/4. So remember, the side with the parentheses, you could just put plus 9/4. But remember, to add it to the other side, it's 2 times that 9/4. And just imagine that the 2's over 1. And so I'm really adding 18/4 to the other side because of that factored out 2. Okay, now ready? Keep the 2. And I know it's positive because this sign here on my b is a plus. And then I got to take the square root of 9/4. So you just take the square root of 9 and the square root of 4, and I get 3 halves, quantity squared. Okay? Then just use your calculator. Okay, so negative 1 plus 18 over 4 ends up being 7 halves. And then you have to bring the 7 halves back to the other side. So I'm going to get y equals 2 times the quantity, x plus 3 halves, quantity squared, minus 7 halves. Okay, my turning point, opposite sign of what's in the parentheses, so it's negative 3 halves, and then the negative 7 halves stays the same for my y-coordinate. Moving on to 46. The method of completing the square can be performed on a standard quadratic equation, and it gives this. It says, based on this formula, okay, what is the x-coordinate of your turning point? Remember, the x-coordinate is always opposite of what you see inside. It's always the opposite sign. So that means the formula would be negative b over 2a. And this might be familiar to you from algebra because you guys did learn the x-coordinate here. Okay? Don't forget, though, it's opposite sign. Part B, using this formula to find the turning point of the parabola. All right, so you first just, I always take the time just to identify what my a, b, and c are. So a is 1, b is 10, c is negative 2. So ready? X is equal to the opposite of b times 2 times my a. So that's negative 10 over 2, which is negative 5. Now remember, guys, that's just the x-coordinate. So to get the y-coordinate, you could just store this in your calculator. So store negative 5 as x, and then you're just plugging negative 5 right here. So it's negative 5 squared plus 10 times negative 5 minus 2. Okay, let the calculator do the work. You're going to get negative 27. Part C says verify your answer from Part B by placing the quadratic into vertex form. When you see the word vertex form, it means it wants you to complete the square. Okay? All right, so now remember, x terms group together, so x squared plus 10x, and I move that 2 to the other side and I get positive 2. All right, oops, I keep forgetting the x here next to my b. It's 10x equals positive 2. All right, b is 10 divided by 2. I get 5. 5 squared is 25. So I do add 25. Now remember, guys, you don't have to worry about multiplying anything because there's not a leading coefficient there. So I'm going to get x squared plus 10x plus 25 equals 2 plus 25. Okay? Now, the square root of 25 is 5, and I take the sign from my b, which is plus, so it's x plus 5, quantity squared equals 27. All right, I bring that 27 back over, and it becomes minus 27. And now I can prove that my coordinates of my turning point are negative 5, negative 27, which we already knew from using that x equals negative b over 2a. Okay, it says verify, part D, verify both answers by examining a table on your graphing calculator. All you have to do is put this equation in, okay, and then put the original equation in, and what's going to happen is your tables will match identically, and you'll see the pattern to know where the turning point is. All right, last example here. Use the formula x equals negative b over 2a to find the turning points for each of the following, okay? So ready, a is 2, b is negative 12, and c is positive 7. So my x coordinate only is the opposite of b, so positive 12 over 2 times my a, which is 2. So I get 12 over 4, and 12 over 4 is 3. Easiest thing to do now is to store 3 as your x, and then just put that in your calculator. Okay, so my turning point ends up being 3, negative 11. Excuse me. All right, a is negative 1/4, b is positive 5, and c is negative 20. So x equals the opposite of b, so negative 5 over 2 times my a, which is negative 1/4. The calculator will do that work for you, but you're going to end up getting a positive 10. Okay, again, store 10 as your x value in the calculator, and then just put in negative 1/4 times that x squared. The calculator knows it's 10, and you're going to end up getting 5.